Let's begin then. Please let me know in the chat if there are any specific questions that you guys have from the worksheets until now, from any of the topics. I would want to discuss them today, along with sequences and sets questions that we will be doing. Okay, you can list them down in the chat. Let me know the worksheet and the question number from that worksheet. Is my voice clear, by the way? And you can see my screen as well. Someone please confirm. Yes. Okay. Quadratics, please specify which worksheet as well, the non-calculator one or the calculator one, and which specific worksheet. Or you can make it easier by just sending a picture of that here as well, if that's possible. So let's start with this. So in the last couple of sessions, we've talked about sets and sequences, right? Sets and sequences, these are two things that we've discussed in the last couple of sessions. Now today, I want to do some practice questions from these two topics in particular, along with any other questions that you might have from any of the previous topics that we've done until now. Okay, so I'm going to start with sequences first of all, and then I'll take your other questions as well. This is what we were doing last time. We talked about the different types of sequences that you need to know of. First of all, we've got linear sequence or arithmetic sequence. This is the term formula for that, the nth term formula a plus n minus 1 times d. You need to remember this. Then we talked about the quadratic sequence in which the second difference is constant. This was the formula that we did to find the nth term of a quadratic sequence, a plus n minus 1 times d. That's the same as the linear sequence, but then you have another term in this, n minus 1 into n minus 2 divided by 2 times d2, where d2 represents the second difference. Okay, second difference is going to be constant, so you can take the second difference. For the first difference, you consider this first value here. Okay, you just input that in the formula, simplify everything, and you get the result. This was another formula for cubic sequence. Generally, it's not tested, but it's part of the syllabus. I haven't seen any question on this in the past papers yet. But in case it comes, this is the formula that you can use for this, where D3 represents the third difference. We talked about this as well. Then for quadratic and cubic sequences, there are two specific types of sequences that you need to kind of remember, squares and cubes, right? Square numbers and cube numbers. Sometimes it's exactly these sequences. In that case, it would be n square and n cube respectively. Or it could start from some other number. Instead of starting from 1, it might start from some other number. In that case, you will have to do n minus something or n plus something. We talked about how to figure that out yesterday as well. Okay. Then we talked about exponential sequences, which are also called geometric sequence. Again, in this case as well, generally, you will be able to figure out some pattern from the given question. Mostly, it's going to be just as straightforward as this: powers of 2 or powers of 3. If there's anything else, generally there will be a pattern in the question that you'll be able to figure out from that question itself. Okay. There's a general formula for this as well, although you would be able to do everything without this as well. It's not required that you remember this nth term formula for an exponential sequence. Then we talked about then we covered some particular examples from this worksheet where we had to spot certain patterns. Now today, I first want to start with this. I want to do some more practice questions from the sequences worksheet, first of all, and then a few on sets in which we have some word problems and we have to solve those word problems using sets. That's the second thing that I want to do. And then I'll take your questions as well. Okay, so let's start with these sequences questions first of all. This is the first one. It says the number of black and white counters in each of these diagrams is shown in the table below. So you have these 4 diagrams above. These are made using black and white counters. Okay, so in the first case, for instance, there's one white counter. In the second case, there are 4 white and 2 black counters, and so on. What they've done is they have listed down the number of black counters and white counters in this table below. So the number of white counters, they go like this: 1, 4, 9, 16. And then the number of black counters, 0, 2, 6, 12, and so on. Okay. Now, first of all, we need to complete the table for diagrams 5 and 6. Okay. Now, how can you do that? We don't have the diagram given, so it's not something that we can count, but we can spot the pattern from this table itself. So we have 1, 4, 9, 16. Do these numbers look familiar? These are square numbers, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the next number therefore should be 5 squared, which is 25. And then the next one should be 6 squared, which is 36. Now it's an exponential sequence, but you did not really have to use a specific formula for the exponential sequence. You could just figure it out yourself if you remember your square numbers well. Okay. All right. So this is 25 and 26. And now we need to figure out the number of black counters. Now, do we see a pattern here now? We've got 0, 2, 6, 12, and then we have to figure out what the next numbers are going to be. Now, if you look at this pattern itself, it's 0, 2, 6, 12. If you look at the sequence itself, it's 0, 2, 6, 12, right? Now, are the differences constant? They are not. We've got 2 here, and then 4, and then 6. The second differences are constant. The second differences are going to be 2. Okay, so if the second difference is constant, it's a quadratic sequence, right? If you're not able to figure anything else out, you can use the quadratic sequence formula. But look at the number of marks that they have. It's only 1 mark. So using that quadratic sequence formula is going to take quite long. It's very likely that you can figure out the next numbers using some pattern in the table itself. Now, can you figure out any pattern? So once you cannot, once it's not fairly straightforward to figure out what the sequence is, one thing you should look out for is there any vertical pattern in the diagram that you have, in the table that you have? Is there any vertical pattern? So look at the numbers vertically like this. Are they following any kind of pattern here? You see, this first number is 0. Okay, the top numbers were both 1. Okay, let's look at the next one as well. The next is 2, and the top numbers were 4 and 2. All right. Then the next is 6, and the top numbers were 9 and 3. Can you kind of make some sort of pattern here? 1 minus 1. If you subtract these 2 numbers, you get the number at the bottom that is 0. So 1 minus 1 gives you 0. In the second case, 4 minus 2 gives you 2. In the third case, 9 minus 3 gives you 6. And then 16 minus 4, that gives you 12. So that's the pattern that you have here. The last row is basically the second row minus the first row. Okay, so the next number therefore is supposed to be 25 minus 5, and that's 20. And then the next is 36 minus 6, which is 30. These are what the next numbers are supposed to be. Okay. Now it says, write an expression in terms of n for the number of white counters in the nth diagram. All right. So at some point, we would have the nth diagram. What's the number of white counters in the nth diagram? Now, we have looked at the pattern. This number is basically square of the number above, right? So this is 4, this is 2 squared, this is 3 squared, 4 squared, 5 squared, 6 squared. So when you have n, this is going to be n squared, right? So the number of byte counters in the nth diagram, we can say that's going to be n squared. And that's what we write there. It's n squared. Okay, let's move on. Now it says, by considering the number patterns in the table, write an expression in terms of n for the number of black counters in the nth diagram. Okay, so now we need an nth term formula for the number of black counters. Now, how did we figure these numbers out in the first place? We subtracted from the number of byte counters this diagram number, right? So it was the second row minus the first row. That's how we figured out those numbers, right? So what is the nth term formula going to be? That should be the second term, the second row minus the first row, which gives us n squared minus n. So this formula has to be n squared minus n. Now it's a quadratic sequence. You could have used the quadratic sequence formula for that if you could not figure out the pattern. But as I said earlier, mostly you will be able to figure out these patterns from the question itself, looking at, you'll be able to figure out the nth term formulas looking at the pattern in the question itself, and you would not have to use that quadratic sequence formula. That's just for a backup. In case you can't figure anything out, then you can just input values in that formula to get to the same result. Okay, now it says, what's the total number of counters in the 20th diagram? Total number of counters. Okay, now we've got some byte counters and we've got black counters. What is the total number of counters? If you were to make an nth term formula for that, what's the total? Total of the first, of the second and third rows. White counters plus black counters. What's the total from these two? You just add them up together, n squared plus n squared minus n, which gives you 2n squared minus n. So the total number of counters is going to be given by 2n squared minus 1 minus n. Now, what are they asking for? The number of counters in the 20th diagram. All you have to do is put n equal to 20 here, and you get 2 into 20 squared minus 20. And that should give you the result. You can see what that is. It's in the calculator paper, so you can just put this on your calculator. 2 into 20 squared minus 20, and that's giving me 780. That's the result that we wanted in this part. Okay, how that makes sense. Let's move on to the next one. So we have these terms of a sequence that are given as follows. T1 is 1, T2 is 3, then 6, 10, 15, and so on. And on the right side, they have given you a pattern that is being followed to get to these numbers. So the first number is just 1, but the next is 1 plus 2, the next is 1 plus 2 plus 3, the next is 1 plus 2 plus 3 plus 4, and so on. Now, we need to write down the next two terms in this sequence. So what's the next term going to be? We just add another 6 to this, right? So we have these numbers, we add another 6. So 15 plus 6, what is that going to be? 21. So the next term is going to be 21 after this. All right. Then the next time we will add 7 more to it. So 21 plus 7, what's that? That's 28. These are the next two terms in the sequence. Now it says the nth term in the sequence is given by this formula. So they've given you this formula for the nth term of the sequence. Show that this formula is true when n is equal to 7. Now we have already written down the value for T7, which is 28. Now they're saying, show that this formula works when n is equal to 7. So what you have to do is put n equal to 7 in this formula and prove that that also gives you 28. Let's try that. So we have 1 over 2 times n. In place of n, we can put 7. And then 7 plus 1. You can evaluate this and see what that is. 7 times 8 is 56. 56 divided by 2 is 28. And that's the result that we wanted here. That proves that this formula is working because the 7th term was indeed supposed to be 28. Okay, so that's the next thing. That was the second part. Now it says use the formula to find T100. Again, you've got the formula there already. All you have to do is put n equal to 100 there, right? So it's Tn. In place of n, you put 100 and you'll get the result. Let's try that. Half into 100 into 100 plus 1. And that should give you the result 100 times 100 plus 1, which is 101, divided by 2. And that is giving me 5050. That's the result that we get for the 100th term. Okay. Let's look at the next one now. It says use the answer to part 3 to find 5 plus 10 plus 15 all the way up to 500. How do you think about this now? It says use your answer to part 3. What have we done in part 3? In part 3, we have found T100. What was T100? We are basically adding all of these numbers 1 plus 2 plus 3 plus 4 plus 5 all the way, look at on this pattern, up to 100. And the result turns out to be 5050. Using that, is there a way to figure out what this sum would be? Any idea? Any idea about this? Is there any connection between this sum and the sum that you've got above? What's the connection? Yeah. So you see, in place of 1, we've got 5. In place of 2, we have 10. In place of 3, we have 15. In place of 4, you would have 20. So every number is basically being multiplied by 5. Every number is being multiplied by 5. Okay. Now, if we were to multiply this whole thing by 5, this times 5, the sequence becomes 5 plus 10 plus 15 plus 20, and so on. This sum would also get multiplied by 5. If you're multiplying every single term by 5, the sum also gets multiplied by 5. So this is going to be 5 times 5050, and that should give you the result 5050 times 5, and that is 25250. That's the result that we get from this. Okay, 25250, that's the final answer that we have. That's part 4 of this. Now, part 5 says, hence find the sum of all the whole numbers from 1 to 500 which are not multiples of 5. Okay, from 1 to 500, all numbers which are not multiples of 5. What are those numbers going to be? 2, 3. So we have to do 2 plus 3 plus 4. And then 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 9 plus 11. So basically all the numbers except 5, 10, 15. Apart from all of those numbers, we have to find the sum of the rest of the numbers. Now, how can we do this now? Sum of all the whole numbers from 1 to 500 that are not multiples of 5. Can we first find the sum of all numbers from 1 to 500, including the multiples of 5? Can we find that total? That will just be T500, right? Sum of the first 500. Both multiples of 5 and non-multiples of 5. We can find that total first of all. Let's figure out what that is. Let's find out this total first, T500, and see what that is. We can use the formula for that, right? Half into 500 times 500 plus 1. Okay, let's see what that turns out to be. 500 times 500 plus 1, which is 501, divided by 2. And that's giving me 125250. That's the sum of all numbers. That's the sum of all numbers from 1 to 500. Sum of all numbers from 1 to 500. That's what we're getting here. We want the sum of numbers that are not multiples of 5. We already know the sum of the multiples of 5 as well. These were the multiples of 5. 5 plus 10 plus 20 and so on. These are all multiples of 5 up to 500. That's what you found in the previous part. That sum was 25250. So if we subtract from the total, that sum that we found in the previous part, 125250, if we subtract from this 25250, we would get the sum of all numbers that are not multiples of 5. What do we get from this? 25250 gets subtracted from there. This is going to give us 100,000, and that's the sum that we were looking for. This is the last part. Make sense? Is that clear to everyone? Is my voice clear for everyone, by the way? Is my internet lagging? You can hear me clearly, right? Okay, so it is lagging a bit. Is my voice also lagging, or is it just the video? Is my voice also lagging? Just a bit. Okay, all right. I think that should be okay. Let me just check this other connection quickly. Okay, I think it might be better now. All right. So that was this one. Any questions in this? Any problems? No problems? Okay, let's move on to the next one. The diagram above shows the diagrams above show the first 4 flower beds in a sequence. Each flower bed contains 2 types of plant, pansies and primroses. I don't know what they are, but that's something. That's these are 2 types of plant. The table shows the number of plants in the first 3 flower beds. Okay, so we have in the first case 10 pansies. Okay, so these plus signs, and then 2 primroses, that's 2 circles. Okay, and the same pattern is shown for all the 4 diagrams. In fact, 3 diagrams, the first 3 diagrams, you can see that pattern here in the table below. And then you have the total number of plants as well, which is just the sum of the 2 numbers above. Okay. First of all, we have to copy and complete the columns of flower beds 4 and 5. You can just complete it on this diagram directly. What about the 4th one? You can either look at the pattern in the table, or since for the diagram 4, you have the diagram given here as well, you can just count from there just to verify that it's correct. So for looking at the pattern, it should be 22 because this is a difference of 4. This is also a difference of 4. So the next term most likely has to be 22 with a difference of 4. But since you have the diagram given, you can verify that as well by counting these plus signs. We've got 6 here. We've got 6 more here. So that's 12, and then these 5 and these 5, 12 plus 10, that should be 22. So yes, this number is indeed 22. Now, that means this pattern is correct. The difference is 4. So the next one should be 26. All right, so that's the first row. What about the second row now? You've got 2, 6, 12, and so on. For the diagram 4, you can just count from the diagram that's given there. You've got 5 in each row and 4 in each column. So 5 times 4, this number has to be 20. Okay, now diagram 5 is not given. So now you need to understand what pattern exists between these two, between these numbers. You have 2 and then 6. What's the difference? It's 4. the next difference is 6, and then the next difference is 8. So the difference is increasing by 2 every time. If you find the second difference, that will be constant, that will be 2. So it's a quadratic sequence, basically. Okay, let's write down the next number after this. The difference is increasing by 2 every time, right? So we had 4, 6, 8. So the next difference has to be 10. So therefore, this should be 30. Okay, and then for the last row, we can just add them up. So this should be 42, and the next one should be 56. All right, so we've completed the table. Now they're saying, find an expression in terms of n for the number of pansies in flower bed n. So basically the nth term formula for the first row. That's what we're looking for. Nth term formula for the first row. If it's the nth diagram, what will be the nth term formula for this? How do you figure that out? This is a linear sequence with a constant difference. What's the difference? 14 minus 10. If you take the first two terms, next term minus the previous term, the difference is 4. And what about the first term? The first term is 10. So you can use a plus n minus 1 times d. That's the formula that we have for a linear sequence. It becomes 10 plus n minus 1 times the difference, which is 4. You simplify this and you would get 10 plus 4n minus 4, which is 4n plus 6. So the first one has to be 4n plus 6. Okay, you can verify this as well. If you input n equal to 1, you get 10. If you input n equal to 2, you get 14. If you input n equal to 3, you get 18, and so on. Okay, so that's the nth term formula for the first one. If you were to use the formula, you can do it like this. Okay, now for the second one, how do you figure out the nth term formula for the primroses in flower bed? And what about the second sequence now? How can we think about this? Now, one way to think about this is that this is a quadratic sequence, right? We already talked about that before, because the second difference is going to be constant. If I were to write down those second differences here, the first difference is 4, then it's 6, then it's 8, and then it's 10. The second differences are going to be 2, 2, 2. So the second difference is constant. What that means is it is indeed a quadratic sequence. One idea is that you use the quadratic sequence formula. That should work. Or you can think, you can try and see if there is any pattern that you can find in these numbers from this table. Can you find any pattern from the table itself? You've got 1 here, you have 10 here, and then you have 2 here. Can we think of a pattern? We've got this number, and then 6, this time 2, this times 2. That's not working. Okay, so right now, I can't think of a pattern from the table itself. Okay, so if you can't do that, in this case, it's not occurring to me quickly what this pattern looks like. In that case, what's the backup? You have this formula, which we discussed yesterday, a plus n minus 1 times d1 plus n minus 1 times n minus 2 divided by 2 d2. You can just input values in this formula. Okay, and you'll get the sequence from that. What's the a? What's the first term? The first term is 2 in the sequence. In place of a, you put 2 there. Okay, then you have n minus 1 times the first difference. What's the first difference? This number here, the difference between the first two terms, that's 4. That's what you use there. d1 is 4. And then you have n minus 1 times n minus 2 divided by 2 times the second difference. What's the second difference in this case? The second difference is 2. Let's input that here. And now you just have to simplify this and you get that quadratic sequence. Let's simplify this. You have 2 plus 4n minus 4 plus 2 and 2 get cancelled, and we're left with n squared minus n minus 2n plus 2. Let's simplify everything now. N squared, and we have 4n minus n minus 2n. What does that become? That's plus n. So it's n squared plus n. And then 2 minus 4 plus 2, they get cancelled. And we have 0 there. Okay, so n squared plus n, this sequence is n squared plus n. Okay. And now that I have found the sequence here, if somebody was able to figure it out directly, that would actually be like this, that n squared plus n can be written as n into n plus 1. So one way to figure this out mentally, which we could not do this time, could have been that this number 2 is the product of these two numbers on top. The number above 2 and the number on the right. So 2 is 1 times 2. That gives you 2. Okay. And then 6 is 2 times 3. That's this number. And then 12 is 3 times 4. That's 12. And then 4 times 5 is 20. So you see the pattern. If you want the nth term of this number here would be the product of this number and the number that comes next to it, which is n plus 1. So that would have been n into n plus 1. So that could be one way that you could figure it out mentally if it clicks at that time. If it does not click, like in our case, we could not think of it the first time we did it. So we use this quadratic sequence. That's the backup that you have. You can use that. But that would be the way to think of this directly if you had to. Okay, so n times n plus 1, you could think of it using the pattern in the table as well. All right, let's look at the next part now. It says, hence show that the total number of plants in flower bed n can be expressed in this form. The total number of plants. Okay, so we already have the number of the first type of flower, the number of the second type of flower. We can just add them. The first one is 4n plus 6. The second one is n squared plus n. Let's add them up together. And that gives us n squared plus 5n plus 6. And now we have to factorize this using middle term breaking. We can factorize this. 1 times 6 is 6. What are the factors of 6 that you can use that add up to 5? You can use 3 and 2. So it becomes n squared plus 3n plus 2n plus 6. N times n plus 3 plus 2 times n plus 3. And you get two factors from that, n plus 2 times n plus 3. And that's what you had to do in this part. That's part C. Okay. Is that all right? That was part C here. Let's move on. Part D. Now it says calculate the total number of plants in flower bed 10. So you can just input n equal to 10 here, and that will give you the result. So we can do that here. 10 plus 2 times 10 plus 3. So it's 12 times 13. 144 plus 12, that should be 156. Okay, you can confirm this. It's from the calculator paper. So that's 12 times 13. That is 156. That's the result that we get. Okay, now it says show that K satisfies, no, there are 306 plants in flower bed K. Show that K satisfies this equation. All right, now how do we think about this? There are 306 plants in flower bed K. That's referring to the total number of plants, right? What we have until now is, let me do it below here. What we know until now is that the total number of plants is given by this formula. Tn is equal to n plus 2 into n plus 3. This is the total number of plants in flower bed n, right? Now they are saying in the flower bed K, the number of plants is actually 306. Now, can we write down the number of plants in flower bed K ourselves? If the flower bed N has this many plants, then flower bed K should have K plus 2 times K plus 3, right? That should be the number of plants in flower bed K. Now, they are saying this number is supposed to be 306. This number is supposed to be 306. So we can equate this to 306. Now, 306 equals k squared plus 2k plus 3k plus 6. Now we can simplify this, take all terms to one side. K squared plus 5k minus 300 equals 0. And that's what they wanted us to prove. K squared plus 5k minus 300 equals 0. That means K satisfies this equation. We don't have to solve this equation yet. They're not asking you to do that in the first part. They ask for that in the second part now. In the first part, you just had to show that K satisfies this equation. That means you can write down this equation in terms of K like this. Now, the next part is straightforward. You just have to solve this equation. You can do factorization for that. It's a 2-mark question. And they're not specifying that you have to give your answers in decimals or anything. That means factorization should be possible. If you can't do that, you can also use quadratic formula. That's also going to work because they've not specified that you have to do a particular method. If you are not comfortable factorizing, which you should be, but if you're not, you can just use the quadratic formula here as well, making sure that you show you're working and you can write down the answer. Okay, how do you factorize this? 300, and we have a minus sign here. So we need two numbers. When we subtract them, we get 5, and when we multiply them, we get 300. Okay, let's think of factors of 300, 30 and 10. Okay, so 30 minus 10, that's not giving us 5. Okay, let's think of something else. 25 times 12 is also 300. That's also not going to work. Okay, we need smaller numbers. 20 times 15. Yeah, so 20 times 15 works. So we can use k squared plus 20k minus 15k minus 300 equals 0. We get two factors from this, k plus 20 and k minus 15. So we have k minus 15 times k plus 20, which means either k equals 15 or k equals negative 20. Okay. Now you have to be careful. What does k represent? K represents the flower bed K. It's the number of that flower bed. So it's going like this: 1, 2, 3, 4, and so on. Can it be negative 20? That does not make sense, right? We can't. We are starting from 1 and we're going in the positive direction like this. We can't have a negative number in place of k. So the only possible answer that we have here is 15. You have to make sure that you cross this answer out, ignore this answer. The only possible solution should be k equal to 15. Okay, that's a habit that you should make. That whenever you have multiple answers to a question, always check if all of them are possible or not by looking at the question statement and the context. In this context, having a negative value of k does not make sense. So we would only consider k equal to 15 here. Okay, let's move on to the next one, part 3. It says, hence find the number of pansies in flower bed K. Okay, I'm sorry about that. In the second part, actually, they just asked us to solve this equation. So for the solution of that, we should write both answers actually. But then in the third part, now they're saying, hence find the number of pansies in flower bed K. We will do that. Okay, I'm just looking at the context again. K satisfies this equation, and we have to solve this equation. Okay, that's fine. So I misunderstood the last part. So that was fine. Let's look at the last part. Now it says, hence find the number of pansies in flower bed K. Now, what's the flower bed K? It's the flower bed in which there are 306 plants, and the value of k is 15 that we found. We are looking for the number of fancies. Do we have an nth term formula for that here? Yes, we found that here, 4n plus 6 for the number of fancies in flower bed K. We found that formula above. That's 4n plus 6. All you have to do is input n equal to 15 in this case. And that should give you the number of fancies in flower bed K. What does that turn out to be? 4 times 15 plus 6, which is 66. That's the number of fancies. And then 306 minus 66 would be the number of the other types of plant, the other type of plant. Okay, so that was this question. A lot of parts, and it had like 10 marks as well, no more than 10 marks, 4, 7, and then 5, 12-mark question on sequences in the calculator paper. I hope that makes sense. Let's move on to the next one. We did this yesterday. As well. Just this one last question, and then we look at some questions on sets quickly. Okay. Now this is one in which we have to figure out some pattern looking at these numbers. It says write down the 7th line of this pattern. Okay, let's look at this pattern. What is this showing us? We have 2, 3, 4, 5. This is the first line, the second line, the third line, the fourth line. What about the 7th line? Now think about it. In each line, this first number is 1 more than the number of that row. So if it's the first row, this number is 2. If it's the second row, the number is 3. If it's the 7th row, what should that number be? It should be 8. So you have 8 squared. Okay, all of them are squares. So the power remains the same. But this number is 1 bigger than this number. Okay, all right. What about the next one? This is 0, 1, 2, 3. So the second number that we are subtracting is always 1 less than the row number. So if it's the second row, that number is 1. If it's the third row, that number is 2. If it's the fourth row, that number is 3. If it's the 8th row, what should that number be? That should be, if it's the 7th row, what should that number be? It should be 6. So we have 6 squared there. Okay. That equals 4 times 4, 4 times 3, 4 times 2, 4 times 1. Okay, so the first number is not changing. The first number is remaining the same in all of those rows. So the first number is 4. But the second number is changing. That's 1, 2, 3, 4. What does that give us? In the 7th row, it should be 7. So you have 8 squared minus 6 squared. That equals 4 times 7. That's the 7th line of this pattern. Okay. Now they're saying write down the nth line of the pattern. So now we know the pattern. We understand that if in place of 7, we had n, the first number has to be 1 greater than the row number. So that would be n plus 1 whole squared. The second number is supposed to be 1 less than the row number. What does that become? N minus 1 whole squared. And then on the right side, the first number is always 4. So that remains 4 times this number. That's the same as the row number. So this should be n. So you can say that's 4 times n. Or in the same pattern, you can say that's 4 multiplied by n like this. Okay. That's the nth line of the sequence. Now they're saying use the pattern to find 521 squared minus 519 squared. You have to use the pattern. You cannot do it manually or on your calculator directly. That's not allowed. You have to use the pattern. Because it's 521 squared minus 519 squared. This looks like the left side of this row, right? So it's 521 squared minus 519 squared. Which row number should it be? If it's 2, the row number is 1. If it's 3, the row number is 2. So if it's 521, the row number should be 520. So it's the 520th row. What is this going to equal? On the right side, we have 4 times the row number, which is 520 in this case. So that should equal 4 times 520. We can evaluate this and see what that is. You have to make sure that you write this down, 4 times 520 first. And then you say, then you figure out what this is. 500 times 4 is 2000. And then 20 times 4 is 80. So this is going to be 2080. That's the result that you have here. This is what you get from this. Okay, using the pattern, it's 2080. Use the pattern to find the positive integers x and y such that x squared minus y squared equals 484. X squared minus y squared equals 484. We have to use the pattern to figure out these integers x and y. Now, there's no way to solve this equation directly because we've got 2 unknowns x and y. We cannot find 2 unknowns from one equation. We have to use the pattern somehow. Now, how do we use that? If we have x squared and y squared, and on the right side, we have 484. What should the right side look like? It's 4 times n, right? That's what we wrote above. On the right side, it's 4 times n. Can we find the value of n? Can we find the row number for this? Let's try that. This is supposed to be 4 times n, right? If it's the nth row, the number on the right side is 4 times n. We can use that to find the value of n. 4n should equal 484, and then 484 divided by 4, what does that give you? That's 121. Okay, so that means this is row number 121. If the row number is 121, what are these numbers x and y going to be? X is supposed to be 1 greater than the row number, and y is supposed to be 1 less than the row number. So what's x? We can say x is equal to 1 more than 121. That means x should be 122. And y should be 1 less than 121, because that's n minus 1. So that should be 120. So x is equal to 122 and y is equal to 120. These are the answers that we get from this. Okay, I hope that makes sense. These were some good questions on sequences. Now let's have a look at a few on sets. Some questions that involve some kind of scenarios. Let's have a look at these questions quickly. Okay, let's have a look at a couple of questions on sets now, involving word problems. So this looks like a good one. In a group of 100 students, 80 study Spanish and 35 study French. X students study Spanish and French. Y students study neither Spanish nor French. This Venn diagram illustrates this information. Now, whenever you are solving word problems involving sets, you should always start from the common part generally, and then, so as in, write down the common part first of all. If you had to write this down yourself, in this case, they've already given that this is x, and then this one is 35 minus x, this is 80 minus x. If you had to fill this Venn diagram yourself, you always start from the middle, the common part, okay? Now they're saying x study Spanish and French, so you've got x in the middle here. Y students study neither Spanish nor French. So this first circle represents those who are studying Spanish. The second circle represents those who are studying French. Neither Spanish nor French means the numbers that are outside the two circles. So that's outside. This is Y. You have this Venn diagram that illustrates this information. Expressed in set notation, the value of X is number of elements of the set S intersection F, right? That's what they're saying. Express the value of Y in set notation. How can we do that? Y is in the region that is outside. How do we describe the region outside? It's outside both of these circles. It's outside both of these circles. One way to describe that would be S union F describes everything that is inside both of these circles, right? But then we have to be outside that. So we can say it should be S union F whole complement. You have to be outside both of these circles. Okay, so that's S union F whole complement. Another way to write this could be, remember that rule that we discussed, if you were to bring this complement inside, the intersection and union signs, they switch. So that will become S complement intersection F complement. Both of them would be correct, okay? Because the second statement means you have to be outside S and you have to be outside F. So if you're outside both the circles, that's the region outside. Now we have to write the value of Y in set notation. What's the value of Y? It's the number of elements in the set. So we would say N of either the first option or the second option, both of them are going to be acceptable, right? So you could say, for instance, S complement intersection F complement, or N of S union F whole complement. Both of them would work here, okay? Now it says find in its simplest form an expression for Y in terms of X. Okay, Y in terms of X. Y students study neither Spanish nor French. Okay, so that's the region outside. What can we do for that? We know the total number of students, that's 100. So we have 4 regions, 1, 2, 3, and 4 on this diagram. If you were to add up all of those numbers, the result should be 100. So we can say 80 minus X plus 35 minus X plus Y. Adding all of these numbers should result in 100. And now we have to express Y in terms of X. What that means is Y needs to be the subject. So we keep Y on the left side, take everything else to the right. Minus X and plus X, they get cancelled. What are we left with? 115 minus X plus Y equal to 100. Y equals X minus 15. When 115 goes to the other side, you have 100 minus 115. So you have Y equal to X minus 15. That's what we get at the end. Okay. Now, these are the tricky parts in such questions. Find the least possible value of X and the greatest possible value of Y. How can you find these values now? Least possible value of X and the greatest possible value of Y. One way to think about this is logically, we have this number X, which is the intersection of both these circles. It's the intersection of both of these circles. We want to find the minimum possible value of this intersecting part, right? Now, the total number is the same. The total number cannot change, right? When you add all of them up, the result has to be 100. We have found this relation between Y and X in the previous part. Y is equal to X minus 15. We want X to be minimum. We want the least possible value of X. Now, how small can X be? Let's say X is 0. Is that possible? Because if X is 0, inputting that here, we would get Y equal to 0 minus 15. That means Y is equal to minus 15. Can this number be negative 15? Negative numbers would not make sense here because Y is representing the number of students who study neither Spanish nor French. We can't have negative 15 students. So X equals 0 is not going to work. if we input x equals 10, that also is not going to work, because if x is 10, y is equal to -5. So y cannot be negative, and x can also not be negative. But what's the least value of x that we can input so that y is not negative? We are subtracting 15 here from x. So x has to be at least 15 so that when we input that in this equation, we get y equal to 15 minus 15, which is 0. There can be 0 students outside, yes, but not negative. So the least possible value of x, therefore, has to be 15. And that's something that you will mostly do in such problems. Whenever you're looking for the least value of the intersection in a Venn diagram, you would generally put the region that is outside, put the number that is outside all circles. You would minimize that number. So you put this number equal to 0, right? That's what you would mostly be doing. That you would want the number outside to be as small as possible. If the number outside is as small as possible, that would also make sure that this number, that's the intersecting part, that's also small. Okay. In this case, you could also think of this using the equation as we did. Since y cannot be negative in this equation, x has to be at least 15. So that's the least possible value of x that we have. All right. Okay, now what about the next part? The greatest possible value of y. Now, greatest possible value of y, we can't really think of that using this equation alone, because we can increase y to as much as we want, and the equation would still work. For example, I could say y is equal to 200, and then I could have 200 equal to x minus 15. In that case, x would be 215. This equation does not have any restriction that stops me from making y 200. But the total number of students is only 100. We have to be careful about that. Now, how do you figure this value? Now, we can use the Venn diagram to figure out this greatest possible value. How do we do that? This number outside, we want this number to be as big as possible. Okay, the number outside, we want that to be as big as possible. For that, we would want this intersection to be as big as possible, because if this intersection is bigger, if x is bigger, then y would also be bigger. Now, how big can this intersection be? What's the largest possible value of x that you can have here? Think about that. How many common elements can the F circle and the S circle have? The F circle in total has 35 values, and S circle has 80 values. What's the maximum number of common values that they could have? F has 35 values. The largest possible number that could be in the intersection is 35, that all of these 35 students are also taking Spanish, are also studying Spanish. In that case, the Venn diagram would actually look something like this. You would have Spanish. Inside that, you would have French. So French circle would become a subset of the Spanish circle. And that would make sure that the number outside is as big as possible. Okay, so when you're looking for the largest possible value of something, you generally will be making the smaller subset, the smaller set, a subset of the bigger set. Okay, it's not just specific to this question. That's what you would generally be doing. I'll write that down as well. You would make the smaller set a subset of the bigger set. So in this case, if the French set becomes a subset of the Spanish set, what does that mean? All of these 35 students are also inside this circle now. So the value of x, therefore, what is that going to become? The value of x is going to be 35 in this case. And if x is 35, what's the number outside? The number outside is going to be 35 minus 15, which is 20. And that will be the largest possible value of y that we can have here. Okay. Now, this is a thumb rule that you will keep in mind, that will work in almost every single question like this. For greatest value of something in sets, and for the smallest value of something in sets. Smallest value of intersecting part, or the outside region. And the same for this. For the greatest value of the intersection part, or the outside region. Generally, that's what they will be asking for. They will ask you for the greatest possible value of this number, or the number outside, or the smallest possible value of both of these numbers, intersecting part or the outside part. For the greatest possible value and for the smallest possible value, what do we do in these cases? For the first case, you would consider making the outside part 0. Okay. So in this case, consider making y equal to 0. That's what we did in the first part, that the region that is outside, that should be 0. Okay. And for the greatest possible value of intersection, or for the outside region, you would consider making the smaller set a subset of the bigger set. So you would make the smaller set a subset of the bigger set. Okay. It's a general thing that will work in almost every question like this. When you're looking for the smallest value of something here, mostly they will ask you for the intersection part or the region outside. You would make the outside part equal to 0. Okay. And when you're looking for the greatest value of something, in that case, you would make the smaller set a subset of the bigger set, like we did in this case. Okay, let's take another question now. Have a look at another question. This looks like a small one. I want to have a look at one that has 3 sets now. Okay, so this looks pretty straightforward because we have the Venn diagram already given in this case as well. Let's do it quickly, and then we'll do one in which we have to draw a Venn diagram ourselves. How many used both bus and a car but not a bicycle? This diagram shows 3 means of transport used by a group of workers. How many used both a bus and a car but not a bicycle? So we have bus and car but not bicycle. Okay, so both bus and car, that's this region, intersection of these two. But they should not be using a bicycle. That means we should be outside the bicycle circle. So we can't consider the 6. The only possibility is this number 17 here. Okay. Intersection of bus and car, but not bicycle. So we just consider this number 17. That was fairly straightforward. Now it says twice as many only used a bicycle as only used a bus. Now, only used a bicycle, what's that number? That's this number here, which they've not written anything for. Let's call this X. Only a bus, let's call this number Y. There were 78 workers in the group, so the total number here is 78. How many used a bus only? Okay, now how can you figure this out? What numbers are we given? So we're not given this and this. Okay, so X and Y is what we're looking for. How do we think about this? Number one, we know the total number of workers is 78. So if we were to add all of these numbers up, what should that be? X plus Y plus 13 plus 6 plus 17 plus 3 plus 15. All of them should add up to what? 78. That's one equation that we get. We can simplify this and we have X plus Y plus all of these numbers. 19 plus 17, that's 36. 36 plus 3 is 39. 39 plus 15 is 54. 54. And then it goes to the other side. 78 minus 54, that should be 24. That's one equation that I'm getting. Please make sure that you are checking for any careless error here. This is the equation that I'm getting. Please recheck the addition there as well. That's one equation. And then they've given us another piece of information. They're saying twice as many used only a bicycle as only a bus. So the number of workers who used only a bicycle, that's X. So this number is X. As only used a bus, this number is Y. What's bigger? Twice as many were X as compared to Y. So X is 2 times Y. What is that equation going to be? X equals 2 times Y. Okay. So they're saying twice as many only used a bicycle. So the number of workers who used a bicycle, that's twice as compared to the ones who used only a bus. Okay. So that means if we were to multiply this number of Y by 2, that should give us X. So the equation becomes X equals 2Y. That's another equation that we've got. Now we just have to solve these two simultaneously to find the values of X and Y. Which one are we looking for? Bus only. That's Y. So we want Y. What we can do for that is we can input X equal to 2Y in this equation. What does that give us? X plus, sorry, 2Y plus Y. If we input X equal to 2Y here, equals 24. 3Y equals 24. And the value of Y turns out to be 8. That's what we were looking for. 8 workers used only a bus. That's the final result that we get from this. Okay, let's try another. If I can find one that has 3 things happening at the same time. We have piano, flute. Again, that's only 2. Car, bicycle. Okay, 2 again. Tennis, cricket, and volleyball. Okay, let's have a look at this now, because now we've got 3 things happening. Let me see if the next one is more difficult, maybe. Orange, bananas. Okay, so this is one in which we have 3 things happening. An activity camp offers 3 sports: tennis, cricket, and volleyball. One day, 50 children took part in these sports. So the total number is supposed to be 50. 19 children played tennis, 34 played cricket, and 23 children played volleyball. Now, first of all, let's make 3 circles here, which will represent each of those 3 different sports. We've got 1 circle here. We've got 1 circle here. And we have another circle here. Okay, so we can say each of these circles represents 1 sport. Let's mark them. So we have tennis, cricket, volleyball. The total number of children who took part in these sports was 50. So the total number is supposed to be 50. Okay. Now 19 played tennis. So inside this circle, the total number has to be 19, but we cannot write that yet. Okay, because we don't know how that 19 is distributed among this region, right? We don't know that. So we can't write it yet. But okay, we've got 19 who played tennis, 34 played cricket, 23 who played volleyball. All right. 2 children played all 3 sports. Now that is something that we can write down directly, because that is the intersection of all 3 circles who played all 3 sports. So we can say this number exactly in the middle, that has to be 2, right? This number in the middle, that should be 2. That we can write. Okay. Now, 5 children played tennis and cricket. Tennis and cricket. That's this. Tennis and cricket. This total number should be 5. So in these two regions, the total number should be 5. If we know that the middle part is 2, then what about this part? This should be 3. 5 minus 2, this should be 3. And then they're saying 10 children played tennis and volleyball. Okay, so tennis and volleyball, that is these two regions, right? Tennis and volleyball. This total number has to be 10. If we have 2 in the middle, how many should we have here? 8. Okay, so that's what we could mark until this point. Now we can use the information that was given there. They said 19 children played tennis. How many regions do we have left in the region where we have only tennis? How many regions do we have left in which, in this tennis circle? There's only one region left, right? The sum of all numbers in this circle, what should that be? That should be 19. So now we can write down the number in this outside region as well. So 19 minus 3 minus 2 minus 8, that would give us the number in this region outside. That's tennis only. Okay, let's write down this number. 19 minus 3 minus 2 minus 8, what's that? 19 minus 13, that is 6. So this number should be 6. Similarly, they have told us that the number of students who play cricket, the total number of students who play cricket is 34. Okay. So this circle should have a total of 34. But the problem is we have 2 regions that are left here. We can't find that yet. Okay, so skip this for now. Let's go to volleyball first. It's the same problem in volleyball, that we have 23 children who played volleyball in total, but we have 2 regions that are left. We can't write that number yet. Okay, we will be able to write those numbers, but let's first now look at what they're asking for. Okay, I'm sorry, something happened to my OneNote. Let's go back to the class. Okay, yeah, it was this one. Now let's see what they're asking about. Find the number of children who played tennis and cricket, but not volleyball. Tennis and cricket. Tennis and cricket, but not volleyball. What's this number? That is 3. We can say that is 3. So that's the first thing that we had to do. We wrote that number. Okay. Cricket and volleyball, but not tennis. Cricket and volleyball, but not tennis. That is this number here. What is this number going to be? Okay. Now, how do we think about that? Let me see the information that they have given here again. 2 children played all 3 sports. We wrote that down here already. 5 played tennis and cricket. We wrote that as well. 10 played tennis and volleyball. But so we wrote that as well. Now, what about this number in this region that is outside, that is outside tennis, but inside cricket and volleyball? That's what they're asking for. Okay. Now, how do we think about this? We have the total number of students here, that is 15. Let's use that somehow. Let's call this number something. Let's call this x, for instance. We can make some equations now. We can say this number is x. If this number is x, what about this remaining number in cricket? We know that the total number of students who played cricket, that is 34. So we can say the number who played only cricket, that's going to be 34 minus 2 minus 3 minus x. And what's that? That is 29 minus x. So this should be 29 minus x. And then similarly, we know that 23 children played volleyball. So the total number in this circle has to be 23. So what we can do is we can write down the number in this region in terms of x, and that would be 23 minus 8 minus 2 minus x, right? 23 minus these numbers, and that becomes 13 minus x. So this number has to be 13 minus x. Now we've got all regions marked there. There's one unknown that is x. We can find the value of x now by adding everything up and equating that with 50. Now, inside the tennis circle, we already know the total number is 19. Let's write that. To 19, now we can add 29 minus x, that's one number. And then x, that's another number. And then 13 minus x, that's another number. Let's add them up together here. This total has to be 50. Now, what does that give us? X and x here, they get cancelled. And we're left with 13 plus 29, which is 42. 42 plus 19, that is 61. Minus x equals 50, right? 32 plus 29, that is 61. Yeah, 61 minus x, that equals 50. X equals 11. So the value of x, therefore, is 11. If x is equal to 11, then 29 minus 11, this number should be 18. This number is 11. And 13 minus 11, that is 2. Now we can write down these two answers. Cricket and volleyball, but not tennis. What's that? That's the number x. We found that. That is 11. And cricket only, that's this number here. That is 18. We can write that as well now. So if we have a Venn diagram like this, in which some regions are unknown, how can we write all of them up? First of all, we start from the region that is common in all of them. So we started by writing 2. And then the others can be written gradually by subtracting from the total this number 2 and then the outside number. And gradually we can get to all of these regions one by one. Once we have the Venn diagram made, we can write down the answers like this. Okay, now try some more questions from these worksheets again. Okay, if you haven't completed them yet, please make sure to attempt all the problems, take this weekend and get done with all the previous worksheets. All right, so that you can catch up with everything that we've done until now. And then on Monday, we start the next topics. On the next month, we will be doing the major topics like trigonometry, mensuration, and a couple of more big topics. That's what we'll be doing next. But for that, it's important that you've covered everything. You've practiced everything that we've done before. Now we're running out of time. Fatima, I will share the solution of that, or I can explain that to you on over WhatsApp, that question that you asked, the quadratics one, question number 17 per D. I will note it down, or it will be easier if you can quickly send me a picture of that on WhatsApp and I'll respond to that, okay? I have to start another class. I'm running out of time here, but we will, I can explain that to you over WhatsApp then. All right, I'll see you again in the next class then. Please complete the worksheets before that. Allah Hafiz.